Well, I'm sorry to interrupt your lunch with this presentation, and I appreciate your attention today. But feel free to keep on digesting and enjoying the spread here. Yeah, my name is Kevin Skerl. I'm the Chief of Natural Resources at Sleeping Bear Dunes National Lakeshore. I've been at the park for 2 years now, so this is my second summer. I just finished up. Previous to that, I was an ecologist for the National Park Service at Cuyahoga Valley National Park in Ohio. And so I was dealing with a lot of similar issues, but in a totally different landscape and a totally different context, totally different Great Lake. But what I'm going to talk about today is basically something I've been thinking about since I came here to Sleeping Bear Dunes, and that is, how do we take all of this talk about climate change and the potential implications of climate change and use it to inform how we manage the landscape? The folks that work for me at Sleeping Bear Dunes, their job is to go out there and monitor, manage, restore, and do all sorts of activities related to the natural resources. And so we're doing things every day. We're doing things all year. We're doing things year after year. Is there anything that we need to be thinking about to consider when, for the long term, what the impacts of climate change might be, and what are the things that we could do to mitigate or manage those potential impacts? And so it's a great concern to me. And so I had charged some of my staff to start asking that question and compile information and say, what does the research show? What are the things we should be concerned about? And I've tried to summarize that for you today in this talk. I don't have any answers for you today, but I have a lot of questions. So hopefully this will be interesting to you. So as already mentioned, Sleeping Bear Dunes was voted in 2011 the most beautiful place in America, and I think that it's a suiting title. 100,000 people voted to make it, give it this designation, and I found it very interesting. And when I was thinking about coming to work here, this was certainly something I considered when making my decision. And so why is it the most beautiful place? Well, it's beautiful because it's been set aside and protected, and it has been, the National Park Service has been charged with preserving it for you and for future generations. And the park has a bunch of outstanding natural features, including forests, all the glacial features that were mentioned in the video, large dune formations, kettles, all sorts of evidence of the glacial period, and also a lot of opportunity for recreation, inspiration, solitude, those values that we're trying to protect. So what are some of the park resources? And here's just a map that kind of depicts the park for you. The park is broken up into 3 sections on the mainland, on the shores of Lake Michigan, and also two of the islands, the Manitou Islands, are shown here. 71,000 acres we're protecting, and it includes 64 miles of Lake Michigan shoreline. That's counting the shoreline of the islands, of course. Some of the main features are these dramatic 400-foot dune formations where the park gets its name. And I mentioned the 2 islands. But recently this year, we had wilderness designated. 32,000 acres of the park is now designated wilderness, which is the highest level of protection that the federal government offers any public land. And so we're very proud that we have that designation. Thank you. There's a lot of wilderness on the islands, but there's also significant wilderness on the mainland units as well. 45. But one thing that I like to talk to people about, and having come from a park that was, largely forested, is this park's largely forested as well. We kind of forget about it when we think about the beaches and the dunes and those features that are most prominent. But 45,000 acres of the park is forest or woodland. There's many inland lakes, 26 inland lakes, as well as large wetland complexes, especially in the south end of the park, but also scattered throughout. And these are just some photos. We saw some beautiful photos earlier on the video. And I just, take a deep breath and say, oh, what a beautiful place. Beautiful wetlands, dune systems, the scrub areas on the dunes. It's ghost forests where the trees have died because the sands have come in and covered up their root systems, and they're just standing dead in that barren landscape. Rivers and streams, beautiful watersheds, a great place to work and live. I know earlier today we had a discussion about climate change and the potential implications and what the models are showing, and I'm kind of throwing up a few slides about that. I don't really want to go into great detail. I'm going to assume that we're talking about the same kinds of things. In this case, increases in temperature are expected in the Great Lakes region over time, and depending on what emission scenario is the one that we'll be seeing in our future, those changes are different. But 3 to 5 degrees Celsius change in winter and 3 to 7 degrees change in summer is what some of the models indicate. Some folks have looked at the local climate data over the last 10 to 30 years and said, are we seeing any evidence of these things? In this case, annual mean temperature at the park, and using local weather information, has shown that we are seeing temperatures that are exceeding the mean. So they're basically on they're extreme measures, extreme values compared to the average temperatures over the long term. So we are seeing some locally significant changes in temperature. Similarly, precipitation is expected to increase in spring, but the summer precipitation expectations due to climate change are kind of patchy. Some models say that there'll be less, some say that there'll be more. We've heard mentioned also that storminess and patchiness and periods of drought, followed by periods of floods. Those are kinds of things that are often discussed as potentials from climate change. And at Sleeping Bear Dunes, the one significant measure over the last 10 to 30 years is that our driest quarter of the year has gotten wetter, significantly wetter. So there are changes that are occurring even in recent years that are evidence of some of this these precipitation effects of climate change. And when we put these two things together, when you put the precipitation models and the temperature models together, what is it that we tend to see? We tend to see a shifting of the climate of Michigan to a more southerly type of climate. First we'll be shifting back to Ohio, and it'll be very comfortable and familiar to me. But then it will continue on its way towards Texas, and I don't really think that that's anything that we've all kind of experienced in the Great Lakes area for a long time. So Ohio, then Oklahoma is kind of a way to think about it.
Kevin, can you stay closer to the mic?
Yeah, sorry. I'm not getting back there. Maybe I should lift the mic up. Is this better?
Yeah.
Turn it. Is that better? Okay. So what are the implications of climate change? That sounds louder. Yeah. The implications of climate change have probably been mentioned earlier today. I didn't see the first talk, so I might be repeating some things you've heard already, but water levels may be lower in Lake Michigan. Some of the models suggest that could happen. Evaporation losses may increase due to reduced ice cover. Temperatures of the lake may increase. Shorter periods of lake ice cover might occur, and stratification periods may change, and previous talk mentioned how they may get longer. Increased storm frequencies, increased droughtiness, expanded growing seasons and earlier springs and later winters, and groundwater deficits, from changes in precipitation in some areas might be implications of climate change. So when we think about those changes that could occur over time, you can think about it if you think about the consequences of that to the natural environment and all the various bits of our ecology and the physical resources of a national park, you can see that we're challenged with a pretty complex thing to try and figure out and understand and do something about if we can. Let's see. So one of those consequences is the basic shift in biomes. So basically the the ecological systems that we see here at Sleeping Bear Dunes and the Great Lakes area are likely to shift, and in fact they show a very high vulnerability for being sensitive to all of these changes from climate change, and you can see that swath of orange going across the Great Lakes area as being highly vulnerable to biome shifts over time. And this map even considers the intactness of those habitats, and thinking about connectivity as being a value that helps buffer the implications of climate change. Even with that, we still see a high risk in the lower Great Lakes. So let's talk about some of these resources in the park and think about what the climate change impacts might be given those implications that I mentioned. So 64 miles of beaches, these huge dune systems. What happens when these things change, these conditions change? Well, what we were expecting to see is increased shore erosion due to decreased annual ice cover. So the fact that there's no ice on the lake leads to longer periods of wave activity acting on the shores, and so erosion rates, while erosion is natural and is part of the system, and that's a dynamic that has been in place for thousands of years, the rate of that occurring will change if ice cover is reduced over time. And so the cycles of sand movement and replenishment, where then the changes in the dune and beach systems, those rates may increase. And so those have consequences for the things that live along the beach, for people who recreate on the beach, people who live near the beach or facilities near these dune systems. These are of concern. And there was an analysis done of the beaches and dune systems in the Sleeping Bear Dunes National Lakeshore, and it was found that 37% of the park's shoreline is at high risk for erosion. And this is located, if you look at these red locations here, some of the most prominent features in the park: the Sleeping Bear Point dune system, Empire Bluffs, which is a great overlook that almost everyone experiences who visits the park, and Platte Bay, we should see has high risk for erosion. And then 18% of the park has risks that are moderate: Good Harbor Bay, Sleeping Bear Dune, and much of North and South Manitou Islands. One of the important resources that we manage here at the Lakeshore is threatened endangered species. We have 2 species that are federally listed that we actively manage and monitor. One of them is the Great Lakes piping plover. It's an endangered species listed federally. 1/3 of the population nests at the Lakeshore. So we're basically an anchor for that population, and we provide the necessary critical habitat for that population to survive and recover over time. This year, 22 pairs of birds fledged 47 chicks, and 22 pairs is 1/3 of the population. So if you think about how endangered this Great Lakes piping plover population is, you can see that numbers are very low, and every single egg is very important. We spend a lot of time and effort at a significant cost to manage the species in the park by protecting nests, monitoring birds, banding birds, saving eggs, working with a bunch of partners to, with the Fish and Wildlife Service and others to provide for the recovery of the species. And much of the shoreline in the park has been designated critical habitat. So the shoreline processes I just mentioned, that things are changing because of climate change, or may change because of climate change, this species could potentially be affected. Pitcher's thistle is a plant that is threatened. It's very locally abundant here in the Lakeshore. In fact, we have one of the 2 largest populations of pitcher's thistle in the country. So it's found throughout the dune ecosystem, and it does very well here. And so we do monitor it, and we manage for it as necessary. But it kind of thrives here in this park. So what are some impacts we might expect? Well, for plovers, nests and eggs are very susceptible to washouts during storms. And so increased storm frequency and flooding during those storms could increase the impacts to that species. we look at plover habitat, we would find that that it's possible that plover habitat would increase with lower lake levels, revealing more of the beach areas and cobbles that they find very interesting and amenable for breeding and nesting. But we might see, because of the shoreline erosion, we might see decreases in their habitat. And with the decreased rates of scouring that are occurring, we would, because the ice cover is not happening and it's not floating up and scouring the beaches, more vegetation growth may occur, and increases in vegetation growth, has been shown to affect how plovers choose their habitats. They don't like to place their nests in areas where there's a lot of vegetation. And so when vegetation recovers, even native vegetation, those species are not doing very well in those areas that vegetation is recovering. There's also a possibility plovers may shift their breeding habitat northward, and I'm going to talk about birds a little bit later in the talk. Plovers may shift northward out and away from some of this very critical, important habitat of theirs. And migration timing may change, which could affect the availability of food when they arrive. The whole food web cycle could be changed by changes in when things warm up, when things cool down. Pitcher's thistle, droughty periods could affect them. They do live out on the dunes. They have very deep taproot systems, and they're very good at living in that dune environment. But changes in the water regimes could affect them. Pitcher's thistle again. The decreased scouring may facilitate growth. So they may be able to establish themselves in areas where the beach is not being scoured as much. I mentioned that earlier for the plovers. It's negative for them. Might be beneficial for the pitcher's thistle, but it may also facilitate the spread of invasive plants who might be able to get established there better and take over those areas and prohibit expansion of habitat by pitcher's thistle. And so invasive species, which were mentioned in the earlier talk, they're a very significant problem in the lakeshore. They aggressively outcompete natives for resources, and they cause damages to the environment, economy, or human health. That's how you define them. But in the park, we have over 150 non-native plants, and many of them are considered invasive, including baby's breath, which you see a photo there of its deep taproot. We have to dig those out, and we spend a lot of time doing that. Garlic mustard in the forests, Phragmites. There's a guy there with a machete looking at a Phragmites stand. Black locust, which is a tree that takes over and dominates through a very aggressive growth pattern. It's something that we're also working hard to manage there. But those are just the plants. We have aquatic invasives, terrestrial invasives. There's a suite of them. And we don't know what climate change may do regarding facilitating invasive species, but we suspect, as was mentioned in the last talk, that invasive species are more amenable to the changes of climate change than the natives are. And so it may become more of a problem going forward. So I mentioned earlier that forests are a significant part of the lakeshore. In fact, 81% of the land in the lakeshore is forested or woodland. 60% of that is beech maple forest. 23% is oak-dominated today. 80% has ash as a component, although that's changing very quickly, as you know. Emerald ash borer has come in and basically killed off most of the ash throughout Michigan. That's not a new issue, and I won't expand upon that. But beech bark disease is another thing that's happening in the park. We're seeing our first patches of tree mortality due to beech bark disease. So the stressors on the forest ecosystem are pretty significant. There are some rare communities that are found in the park. Black ash swamps are one of those. Old growth cedars are on South Manitou Island, which is a rare find and a great resource. Spruce, fir, cedar, and birch communities are also scattered throughout the lakeshore. But as I mentioned, the stressors on these forests are already in place, and so we think about, well, this is a significant ecosystem in the park. What is what's the long-term effect of climate change? Well, the long-term effect that's been modeled by many researchers, is that we're going to see a shift in species composition and the kinds of trees and communities that are going to exist under different climate scenarios. And so you can see here that under the higher emission scenario, what we're going to see is beech, maple, birch, spruce, fir, aspen, birch. Those communities are all going to see a decline in the area. We're going to lose those species, and we're going to see oak-dominated communities become more prominent in northern Michigan, including the lakeshore. Although, if you look really closely at these maps, it doesn't really include Sleeping Bear Dunes. We're a data gap in this in that data set. There's no data for our park because of how they set up those plots nationally. I think the forest plot ended up in the water or something. Another way to look at it, if we look more specifically at some of the species that might be of interest or of concern, if we look at quaking aspen under the increased, the emissions rate, which is, as we move down the charts here, quaking aspen should move out of the area and no longer be found. Excuse me. Sugar maple, which is a big component of our forest here, is likely to move out of the area as well. And white oak is likely to move into the area and become more established. And so these changes are not just about trees, of course. They have these cascading effects that affect mammals and birds and fungi and insects and all of the whole entire food web is tied into changes in these habitats on this kind of gross scale. And so what a complicated set of changes to anticipate when your forest is going to change from one type to another over time. So forest stress, that we would expect under climate change include kind of facilitation of the pest and disease problems that we're already seeing. We'll see reduced tree growth and seed production and increased disease susceptibility. We might expect to see increased insect pests because they'll have a longer period of time by which to, and maybe multiple generations in which to reproduce during the summers. And the winters, maybe if they're milder, they might not have as much winter kill on them. Large-scale ecosystem changes, which I've just mentioned, and also cascade effects in other habitats and other ecosystems in the park. I'm just talking about forests here, but you can say the same kind of thing is expected in wetlands, in the open grassland shrub areas. All of those communities are going to see similar types of changes and shifts because of changes in precipitation and temperature regimes, if the models are all borne out. So one of the topics I like to talk about, and it was kind of skirted here in the previous talk, is this issue of avian botulism, because it's kind of an example of one of those complex systems that has some pretty good. There's pretty good evidence that climate plays a role in this cycle. Avian botulism is something that's the Lake Michigan has been experiencing, and some of the other Great Lakes have been experiencing over time. And basically, it's a cycle where those invasive mussels have cleaned the lake. More light is getting down to the bottom. The Cladophora algae is growing more. It's getting sloughed off during storms and deposited into small depositional areas within the lake. And in the right conditions, it is creating anoxic conditions so that the botulism toxin, the botulinum neurotoxin, which is found everywhere in the environment, has just the right conditions to reproduce. And then the invasive gobies go in there and swim around in it and get intoxicated. And our diving birds, like our loons and grebes, are out there eating these intoxicated fish, and then they're ending up dead on the beach in the lakeshore. In fact, in 2007, we had a big outbreak year. We started our monitoring program. That year, we had over 4,000 dead birds wash up on lakeshore beaches. And last year, only 434, and very light this year. And I'm going to explain why in a second, why we think that is. And it is related to this climate change topic. Often found on these beaches are common loons, which is a state-threatened species. We're kind of at the southern end of its range here, its breeding range here in northern Michigan. And it's typically affected, and that's unfortunate because these are long-lived birds, and we're seeing like hundreds and hundreds of them dying, and you can imagine we're only seeing a fraction of those are washing up, floating and washing up on our shores. Decimation of the loon population is a sad thing to be witnessing. And this is a complex issue. I just kind of mentioned that food web that's proposed. It's being investigated by researchers at USGS, University of Wisconsin, Milwaukee, a bunch of collaborators throughout the region, too many to actually name. And our part in it is, we're kind of dealing with the birds on the beach and facilitating all the research in Lake Michigan and trying to assist in any way we can. But those invasive species drivers are really significant. But why did we not see a great outbreak this year? And we think that it's related to some drivers of this that are related to climate. This information was compiled by Brenda LaFrancois and Stephen Riley. Brenda is one of the an aquatic ecologist at the National Park Service's Midwest region. She's been doing a lot of research in the park, and she took a look at two drivers that were kind of implicated when we look back at the data, why avian botulism outbreaks might be occurring. One of them is the Lake Michigan lake levels. And even recent trends, you can see on this chart that small outbreak years have the lake levels are high, and during big outbreak years, lake levels are low. And if you look at water temperatures, we see during small outbreak years, lake temperatures are low, or outbreaks are low, and during big outbreak years, the lake temperatures are high. And so when the lake is low and the temps are high, we have a big outbreak. When the lake is high and the temps are low, we have just the opposite. We have a low outbreak year. We all know this year we had a high lake levels, we had frozen lake, we had cold waters for a long period of time. We were predicting we'd have a very low outbreak year, and we are having a low outbreak year. And I do have some other graphs that kind of show the regression models that they've run on the long-term data as well as the short-term data, and they have looked at these trends and found a pretty tight relationship. Predictability of 75%, explaining 75% of the variability in the outbreak levels based on these two measures. And so while all these other things are complicating the story, it seems that climate may actually have some effect on whether we see avian botulism outbreaks. And so that's important for us to understand if those things are going to change going forward as a consequence of climate change. So I mentioned birds, so let's talk a little bit about birds. In the lakeshore, we have 240 species that have been identified within the lakeshore, and we know in the science that there's already been observed breeding and winter distribution changes for many bird species. And this year, Audubon put together a kind of a modeled approach at looking at a bunch of birds and trying to understand what the potential impacts of climate change are. And from their perspective, and according to their report, there's 314 species that they consider on the brink due to climate change effects. And they put together a variety of different ways to look at it, but the maps that they provided on their website are really interesting to take a look and say, it's similar to those ideas that we looked at already with the forest. How are things shifting? There's this idea of everything shifting northward as things get warmer. I looked at the list that they've compiled for the state of Michigan, and the top 50 species that show the greatest change in their current summer ranges. So the greatest amount of loss of current summer range, which translates to, are those birds going to be where we see them today in the future? The top 50 in Michigan, all of those birds are found in the lakeshore. So, we could expect to see changing bird populations in the park as a consequence of climate variables according to their studies. I'll give you a couple examples here. The yellow on these maps represents the current breeding areas, and as you can see, the common loon, which I mentioned earlier, It has a breeding range that extends into the northern U.S., extends into Michigan, Minnesota. It's a very common species to see breeding in the summer there. It's kind of a harbinger of spring. But they're predicting that 56% of the current habitat that it breeds in is going to change over the next 80 years or so. And so you could see that would make the common loon shift northward and out of breeding in Michigan altogether. So that's what this map kind of depicts. We can take a look at another species, a chestnut-sided warbler, which is a cute little bird that breeds here in northern Michigan. They're predicting that 88% of its current range is going to change over time and shift northward. In fact, it does. If you do the quantities here, apparently it does increase the amount of area where it can breed, but it won't be here any longer. It'll just be breeding further northward. So we can see losing that species. So there's a whole list of these that we might expect as changes that could happen due to climate change to the bird composition at the lakeshore. And I could get into a long discussion about all the other kind of cascading effects, and I didn't want to get into all the different topics that we could kind of run down. But it kind of gives you the idea of how complex it is, the kinds of issues that we're facing looking at, just things like forests and birds and, just the dunes, these very big, obvious resources. But the complexity goes into every ecosystem. Wetland and stream ecosystems, we'd see that any effects on that increased drought, groundwater charges, frequency of storm events, those could affect wetland and riparian areas, stream habitats. We'd expect to see changes and consequences there. What's going to happen to our mammal population? Studies are kind of coming up with a couple ideas of how mammals might respond to climate change. Your larger mammals like your white-tailed deer or your coyote are going to respond differently than smaller animals. Apparently, the smaller ones are more adaptable to climate change and finding niches in current environments. But also those that have behavior. A recent paper says that mammals that either do all their activity during the day or mammals that do all their activity at night, like bats and possums, those things are going to be more susceptible to the impacts of climate change than those that utilize the day more generally. We might see fire frequency increase. Why would we see that? Well, increased tree mortality increases fire loading. Droughty periods, if they're extensive, could lead to what we call fire weather, appropriate conditions for fires. Dry, windy, lots of fire loading, fire frequency could increase. Currently, the lakeshore has a low frequency of fires. I would say 0 to 3 fires a year occur within the lakeshore. We haven't seen a fire I think only 1 fire since I've been here, maybe 2. Nothing of any significant scale, but that could change, and that would be a very big concern for us as managers. And then phenology changes. This is kind of one of those complicated ecological questions. Phenology is the timing of life history stages, and actions like migration, flowering, pollination, when you breed, when you leave an area during migration. Those things are all going to change if all the climate variables change, and they could get disconnected from one another. So, it might get warmer earlier and flowers are blooming, but the life cycles of the insects aren't matching it. Birds might come back earlier during migration, and they'll find that their food source hasn't yet erupted. With the disconnection and discontinuity between, these various elements are very complex and hard to predict. All we know is that changes will occur, and who wins and who loses, very hard to determine. A lot of people studying very specific things about it, hard to think about it on a park scale. I'll translate this to a visitor experience as well, because this is, the changes that we see at the park affect the people who come visit the park. I mean, we saw this video before my talk here that shows how beautiful the place is and what it means to you as a person, and what it means to have an experience there. Well, how your experiences change. Well, we might see increases in nuisance algae. That's Cladophora on the shore there, and we see that periodically now. While we could see more of it, increased storminess could bring more. In addition to the cycles that are already happening in the lake due to invasive species. We could see increased beach closures because, again, storminess also pulses the system, and that's when you likely see some of your higher bacteria loading in your public beaches. So we could see a problem there as well. The insects that spread Lyme disease and West Nile virus may benefit from longer summers. And so you may have increased exposure as a visitor or a user of the outdoors to those diseases. There's already a long talk about changes in the fisheries, so I'm not going to touch on that. But you could, fishing opportunities, recreational fishing opportunities could change based on a variety of factors. Increased invasive species in our lakes, especially those that inhibit access with boats, could affect your ability to get in and out of some of our fine inland lakes. Bird watching opportunities would change. I just mentioned that you're going to see different birds, maybe fewer birds. You may see a lot more of some birds and very few of others. I mean, there are going to be, I'm kind of talking about all the bad things, right? All the things that are going to change. Well, there are going to be kind of the flip side of that. Something's going to take advantage of these conditions. Your generalists, your year-round residents, those birds, you'll see a lot more cardinals and house sparrows and the things that you already see a lot of, you'll see a lot more of, because they'll likely be able to adapt and stay within the niches that are available to them better than those that are more adapted to specific conditions. Fall colors will change. We're going to lose ash. We're going to lose beech. We're going to lose maple. Oaks are pretty sometimes. Oaks will move in the air. But I mean, you're talking about your yellows and your reds and your oranges and some of the most vibrant fall colors is something that we could see. Take a look this year. Take a look. Because some things are going to change, and those are some dramatic changes, and that's just aesthetics, and I understand that. But still, it's a part of the place, and it's a place that we manage for the benefit of future generations, and it's a concern when we see these experiences change. But let's say good things. Longer summers, yay. More recreational opportunities in the summer. But I like to ski. Shorter winters. So it's the recreation opportunities are going to change. The period of time will change. So what can we do about it? I mean, this is we think through it. We say, there's all these connections to climate change. The potential for impact is wide ranging. Depending on the emission scenario that is really going to play out, and we don't really know if the trees are going to move in. Really move into the area. We're talking about climate models. We're not talking about soil models or whether there's actually a means for migration of those tree species. There's a lot of questions from the things I just presented that when it gets on the ground, it changes what you can do or how you should do it. But you have to think about it from our perspective. We could just continue doing what we're doing like we think we should do it and never consider this, or we can try and anticipate what climate change challenges are ahead of us and make sure that what we're doing today is nesting within some reasonable expectation of what the climate might be like in the future. So one of the things that I put a quote here from one of the reports on natural resources, the natural resource assessment of the park that was done in 2009. Climate change poses a grave threat. Well, yes, I agree. I think it does if you think that you have to try and fix everything. I think there's a lot of things that are going to be way beyond anything we can do in a national park. But we can find those things we can do and try and focus on those. Vulnerability assessments, those are evaluations of what are the resources that are most vulnerable. I've given you kind of a taste of some vulnerability assessments today. But we still don't know things like what is really going to happen to piping plover breeding habitat. Is it going to get better or worse? Are birds really going to shift or not? Those are really important things for us to know. We don't really know that. We just have ideas about it. So then we have to develop adaptation plans. We have to think about what about the programs we have in place? How do we change them and incorporate consideration of climate change into our actions. Do we start restoring more habitat on the northern end of the park? Do we restore species in an area that are likely to be more amenable to a future climate and not focus on those that are likely to be leaving? Those are questions we have to ask ourselves, and they drive restoration efforts. We do plant things. We're always planting things. We're planting dune grasses. We're planting trees to replace those we're losing. We're removing invasive trees and trying to replant native ones. Taking into account climate change into those planning efforts is something that we're beginning to do. We also facilitate research. We're encouraging folks to use the national parks as your laboratory. They're your public lands. They're there for you to study, and we encourage people to come and do that. We actually have one climate change study going on that's very directly involved or related to climate change. Lucas Beldereski from University of New Mexico is looking at dune grass communities under different precipitation regimes. So he's developed an irrigation system, different communities with different biodiversity mixes, and trying to see how they respond to different precipitation regimes, as it kind of mimicking what future climate change scenarios might place on that ecosystem. And so that research is just, it's been going on for, I think, 3 years now. And then also there's things we can do to mitigate climate change impacts. And when I say mitigation, I mean do things like change our emissions at the national park. One of the things that we're doing is this year the park revealed the work that we've been doing under the Clean Cities National Parks Initiative grant from the U.S. Department of Energy, and with technical assistance from the Clean Energy Coalition, which is based here in Michigan. We're replacing fleet vehicles, aging fleet vehicles that are polluting and high emission, with plug-in electric vehicles, propane pickup trucks. We're providing electric charging stations. A tire inflation station's been installed at the visitor center, because tire inflation and tire pressure, increases your gas mileage in your vehicle, and we want to encourage everybody to get every mile they can to reduce emissions. And we also provided, we developed a motor pool structure for our vehicles in the park, so we're choosing the least emission, the lowest emission vehicle for the task at hand. And we also did eco driver training for all of our employees on how to save on gas and fuel and that sort of thing. So this is an effort that we can do, and we know it's just a little piece of the puzzle, and but it's a way that we can demonstrate that we're taking it seriously, and encourage others by leading by example to think about this in their own lives. And so mitigation is something that we can do on an individual level or at a park level, and we're making attempts ourselves to do that. I'd like to acknowledge from my talk that I didn't dig up all this information alone. I had a few employees and interns that helped compile some of this information and reports. Leah Wergau was an intern last year for me. The year before that, Andrea Lysott was a seasonal who helped kind of pull together a lot of the research that had been done on the national park regarding climate change. Brenda Marasca-LaFrancoise, the NPS aquatic ecologist, I stole some of her slides. And Lucas Beldereski also provided me a few slides, especially on his research and some of the climate change ones I used in the beginning. So I want to acknowledge those folks because I borrowed liberally from them. So I'd encourage you to propose any questions to me. I'm happy to answer them. And if you have more information, if you want more information about the national park and what we're doing, national park system, and what we're doing about climate change, you can visit nps.gov/climate change. There's lots of stuff going on throughout the parks. We're dealing with parks that have glaciers and parks with huge watersheds and larger ecosystems even than we have at Sleeping Bear. So and some interesting mountaintop populations. All interesting questions relating to how to adapt to climate change issues or climate change effects. So thank you.
Do you expect an increase in tourism, human tourism?
The question is, do we expect an increase of human tourism in response to?
Climate change.
In response to climate change? I don't know. I suppose, I suppose if you have longer summers, that more people come during the summer. We do have our highest visitation in the summer, so I suppose that would not be an undue expectation. Yeah. Yes.
How much of a Phragmites problem do you have?
The question was about Phragmites in the park. We do have Phragmites at several stands in the park, but we do actively manage it at a couple of our wetland areas. I know for a fact Tucker Lake wetland has Phragmites in it, and we've been treating it for several years, trying to keep that population down. It's not as significant of an issue as it was at my previous park, but that has a lot to do with salting of roads and the contributors to Phragmites getting into systems being a little bit different here. Yes.
How do you handle the garlic mustard in your woods?
How do we handle it? How do we handle garlic mustard? We pull it by hand. And we organize large volunteer groups who volunteer a lot of their time liberally, and we're very gracious for their help to pull bags and bags and bags and bags of that stuff out of our forests. Yes, back there.
How do the cuts in the federal appropriations for the national parks affect your efforts on adapting to climate change and restoration?
So the question was about funding of the National Park Service and any cuts and how they might relate to how we can adapt to climate change. Well, we've been lucky in one respect that we've been able to get funding through the Great Lakes Restoration Initiative to do a lot of the invasive species work. Yes, a very great decision and been very helpful to Sleeping Bear Dunes in particular. We've gotten hundreds of thousands of dollars to get people on the ground doing work that benefits directly the Great Lakes ecosystems, invasive treatments, restoration, research, water quality monitoring. All of those things are being funded through Great Lakes restoration dollars. So that's been a helpful way to buffer ourselves from any of our base funding issues. And there's other things out there that we're hoping are continue to be attracting attention and funding to these issues in our natural areas. Yes.
I get letters from the Yellowstone Park, Grand Canyon National Park, join to save. Do you have an organization like that?
Yeah. So the question was, do we have a friends group? Is that right? Yeah. Yeah. The Friends of Sleeping Bear Dunes is our friends group. They're officially our partner, and they have indeed provided additional fundraising capabilities for certain projects in the park. A lot of visitor facilities, but also some natural resource programs as well.
One more question.
Yes.
Oh.
What? Whoever, yes.
Yeah, how are you handling I understand that there's some question about the beaver taking down beaver dams because of pressure for higher water and from people who don't like it. How's that being handled in the lakeshore?
Yeah, so the question is about management of beaver and beaver dams as it relates to flooding of private property. Right. Well, under the National Park Service policies, we're fully within our ability to manage native species when they are either harming human health and safety or causing damage to property and infrastructure. And so in the past, the Park Service certainly has taken it upon itself to manage beaver and, at times where those conditions are met. Currently, we're working with folks on the Shelda Creek watershed. We've actually what we're doing is we're conducting a bit of research to better understand the dynamics of that watershed, to understand whether beaver dam management actually does translate to any benefits upstream to the Little Traverse Lake area. And because there are arguments to be made that the evidence is that under high flow conditions, culverts at various locations along the stream are the problem and issue causing flooding. But there are also evidence that under low flow conditions, beavers do tend to raise the water level in the system upstream of their dams to some extent. How far that translates upstream is a question we're trying to answer currently. And but we have no program in place for management of beaver dams to address that issue. We're only researching that issue at this time. Thank you.